Okay, thank you, everyone. I start recording. Hopefully, you can hear me, and I'm also sharing my browser. Um, just to make sure that you hear me, just someone say yes, and you can see my slides.
Yeah,
I
we
can
can
hear
hear
you,
you.
Kobe.
Thank you. Thank
Yes,
you,
Kobe,
folks.
no problem.
Okay, welcome. Let me, I'm gonna do something which I usually don't do. And I'm going to turn on camera for some time so you can see me. I'm gonna blur some so you don't see family behind me. Once again. Okay. So thank you for attending. We have a very busy meeting today. So this is our 16th meetup. Today, July 14. I just want to mention that the meetup fees are paid by Qualcomm WRD software that I'm part of in San Diego, and our VP is supporting this group. So thank you, Charles Bergen. He's a big supporter of this group. So thank you for that. This is the agenda. So as I'm saying every meeting, I'm going to just talk about what we're trying to do here, what are the rules, and not a lot of rules, but we do want people to present, and we're working with people that present. We have Arvind that is going to present PMR in CPAPA 17. It's a fascinating subject, in my opinion, that can be used in all kinds of memory constrained environments and kind of having fun from both worlds. So he has a very good talk that he's going to have soon. We basically want to hear feedback if you want to talk about a specific topic, or if you want to raise question or anything, please do. You can even have a snippet of code that you want to talk about and ask people in the community how to do it. And the idea is really build community here in San Diego and beyond San Diego, because we have multiple people from different locations, different location in the world, not only in California or in the States. So first of all, thank you for coming, like showing up. It's different time zones. I know it's difficult. So yeah, the idea is basically to kind of create this community and talk about everything in that you want to talk about C++. So that's about it. I'm just curious, like, if you can raise your hand if you're new, just to see how many people are actually new to this group. I see that we have about 31 people total, and yeah, there's I don't know, about half maybe new. So welcome. Good to have you on board. And let me switch back. So when I created the agenda, initially, usually I use my weekends to work on the agenda. I need to think what can be useful and what can be interesting. So I build usually more than I like, just to make sure I can fill the 2 hours. I create more content sometimes than I usually have time for. And fortunately, I mentioned I have Arvind that would have he has a talk about PMR. So I'm going to do the following. We are going to skip some of the bullets here because I want to make sure that the PMR and the WebAssembly. So I'm going to have a WebAssembly talk after the PMR, and then if we have time, we can go back to the other things like lead code and C++, Stack Overflow, demand, and so on and so forth. We'll have maybe 1 or 2 C++ quiz because it's always fun. And yeah, the lightning talk we'll keep it to the end if we have time. Otherwise, we're just gonna push it to the next meeting. I hope it's fine. I just want to make sure that the main dish of the agenda is served. So we have a Dropbox where I push my slides and any presenter slide into this location. So this is the link. We have a Slack channel. I'm on the Slack channel. It's pretty dormant, like people don't use it. In Qualcomm, we actually have kind of an active team channels, and we have all kinds of tips that we provide, and kind of a weekly session, kind of interactive one. And recently, Brian Busker, which he's someone that is working in my department with me, different project, and he's kind of co-hosting with me the channel. We both have CMake, and actually this is kind of more active than the C++, believe it or not. People actually apparently like to talk about CMake. So we have a lot of these actually activities happening inside Qualcomm. And if you're part of Qualcomm and you're not part of this channel, let me know. We can add you, or we can send you a link. Oh, we have the YouTube channel that we post. We have so I'm actually uploading the YouTube channel. I have permission from my VP to do that. So that's something that I do. We don't talk anything proprietary here. So that's strictly C++ stuff. We don't have everything recorded, obviously. So we just recently started recording and started uploading. We have a new C++ Meetup Twitter account. I'm owning it, of course, but it's kind of a separate space for me. I have my own Twitter handle, which is Kobe_CA. You can also follow me on that one. I tweet a lot about C++, CMake, sometimes Python, software architecture in general, Linux, Shell, all of this cool stuff. I'm trying to kind of tweet and retweet some things that look interesting to me and for others. Okay, so let's talk about the GitHub repo. By the way, is there any, before I continue, is there any question? No. Okay. You can definitely stop me if you have any question, and I'll be happy to talk about anything. So the GitHub repo of the month, I have millions of repos that I'm starting just for the sake of sharing that with others. This is just one of them. Upsil, I don't know if I pronounce it correctly. So this is basically from Google, and it's been around for some time. At the time that I actually captured this screenshot, like a few weeks ago, it had 7K stars, and it's kind of a library that hosting a lot of utility classes that either missing from the standard or kind of improving the standard. For example, string view was in Upsil before it was actually, we had C++ 17 finalized, so people actually used it. There are some small differences I know from like compared to the standard. I don't know if it's a fully compatible. I know that some of them are not, but it is a very it is Apache 2.0, so some of you can use it, some of you cannot. But it's a good library if you want to have some one repository that has a lot of utility classes to use, and you can really use maybe a later compiler. So that's one of the things you can use. It's like Boost. It's not really Boost. Like Boost gives you all these nice libraries and containers and all of that. So just like Boost, it has a lot of alternatives to the standard. This is another alternative to the standard that you can use. So that's one thing that I wanted to share. We're gonna skip the spaceship operator from CPPCon 2017. I was thinking to have this and this sliding dock, and also have a full talk on the spaceship operator. I'm kind of torn. It looks very simple if you use it, but there's a lot of corner cases that we need to talk about in order to kind of fully understand the spaceship operator. And in a nutshell, it gives you the ability to provide simple syntax to your user-defined type to compare it compare instances of this type, instead of having this boilerplate code that you need to write. So we're going to skip this one. Let's do some C++ quiz, because it's always fun. Okay, so difficulty would be light. And let's take a look at this. You can see this. You can see the question, right? Okay, good. I just want to make sure that no one is actually looking. So I don't remember if we've done that once or not, but let's give it a try. So there is two types here, class A and class B. Class B is publicly inheriting from class A. Class A has a virtual function, and class B has the exact same signature. It doesn't have virtual, it doesn't have override, but it's still it's a virtual function, and both of them have stood C out. One is A and one is B. I think we had that before. I'm kind of recognizing this. And then we have a function G that takes A by value. This is important, and then calling F from A. So we have B in main, B instance, and we call G with B. So what do you think would be the and you can just unmute yourself and just shout the answer. So the hint is that this whole virtual mechanism is actually happening through references or pointers. If you don't have a reference or pointer, that's a hint that you're not actually going through the virtual mechanism. So that's a hint.
It's going to be A.
It's going to be A.
Yeah.
Okay. Why? So what we have here is what we call kind of slicing, because again, the whole mechanism of virtual function goes through a reference or a pointer, which is basically internally it's kind of the same. So when we pass B to A by value, we kind of slicing B, and what is left is only A. So it's not like we have a pointer to A that basically pointing internally to the B instance. It's actually, we don't have a B instance inside function G. Okay, I don't know if someone is looking for me. Let's see. Someone is. So if you're raising your hand, do you wanna say something? Go ahead and say.
Yeah. What if G was a inline function? Would it still be the same? Or
if G would be an inline function, which by the way, it is an inline function here, because it's like the compiler would definitely have everything inlined. So that, okay, let me just make it and just do it. So let me see. Let's just have clunk. So it was, to be honest, it's implicitly inline. Let's run the compiled output. And it's A. The question is, what happens if it's a reference? It's going to be B, because we are actually invoking in that through reference or pointer, then the mechanism, the virtual mechanism would kick in. Any question on that? There's a lot of things that we can do. So please ask me if you have anything.
What if it's an R value reference?
If it's an R value reference like this?
Yeah.
Okay. So first of all, we need to make sure that we can bind B to an R value reference. So how do you think we should do that? By the way, your name is? Michael, I want to start getting people to know people. Usually I was doing it face to face, and it was pretty fun to see people in person. But now unfortunately it's okay. So we need to move it, right? So the question is, first of all, what is std move? Let me just make sure that we don't want to spend more than 8 minutes, so I can have the PMR thing. What is std move? Std move doesn't move anything. Std move is just casting to our value reference, right? So now I can actually bind B to A ref A. So what happened here? It's B. So apparently, actually, it's a good question. I didn't like 100% kind of. I just guessed it in my heart. In my mind, I just guessed the question, but the answer. But apparently this is still considered to be a reference, but just our value reference. That's fine, but it's still a reference, so it's not slicing. We still have B inside, which makes sense. So our value reference is just reference. It's just the committee said, okay, we're gonna add another way to bind to a non-const R value. So this is what we have here. It's a non-const R value.
I'm sorry, but what would happen if we pass by pointer reference?
Okay, let's take a look. So just remove all of this, right?
Right.
And what you're saying is, so this is by reference. And you're saying by pointer reference. This is interesting. Let me see. Like this? Pointer reference? I don't know. I don't know what the syntax for that would be. I don't know if there is something
the other way, Kobe.
The other way.
The other way.
Yeah.
Okay. Yeah. Oh, yeah.
Doesn't like it. Yeah, because I need the arrow. Now it's a pointer. So it doesn't like it because no matching. It cannot convert from B to a reference of
If you remove ampersand in the G.
Yeah, if you remove ampersand, that's fine.
Yeah.
That's just a pointer. But I to be honest, usually I'm not
like you can have a reference to a pointer that you're just implicitly creating with the ampersand operator, right? So would it have to be an actual pointer type, like an actual pointer variable, to have a reference to it?
You're saying keep that. Right?
Yeah, and then in main, create a B pointer and see
right.
if you can pass that. Create the B and then take the address of it.
Just take the address of it, like something like this.
Like B2 pointer
B2, yeah, B2
ampersand B
equals new.
And have B2. Let me see. I don't know. So it doesn't.
No, I still can't convert that to an A pointer reference.
Yeah, I don't know. By the way, if I see such code, I'll ask the author what exactly, because it is confusing, at least for me, but I don't know. But it's we can research that and see what. I don't know if anyone has anything to say about this specific use case, but if not, we can just continue.
Well, the reason I think the one time I needed to use that is when I was deleting like a tree or something like that, and if you pass the pointer just by value, then it wouldn't really work.
If you pass the pointer by value, well, if it's I think that, I don't know, just don't quote me that. If you're still in the pointer domain, I think as long as you don't have slicing, we'll get B. I think this is the bottom line. Like if we think about a way to represent this syntax, like to actually be able to bind this correctly, it would still be output B, I think, because we're not doing any slicing. That's at least my opinion, but can't guarantee that. I need to play with it. Okay, let's have another one, and then we'll go to PMR. Actually, I have another couple of things to say before PMR. Let's see. Okay, let's do next. Next question. So this is a bit more difficult. According to CPAPA 17, so we have a constructor that says 1, a copy, constructor that says 3, constructor says 2, and then a function that says 4, and then an object that is constructed. And then, we actually had that. We had that before. Right? I think we had that. So take a look at that and tell me what you think. So I'm going to just kind of speak on that one. So this object is going to be created, right, before main. Do we agree on that?
Yes.
Probably.
Yeah. So it's going to be 1 because it's created, and it's going to probably distract last. So it's going to be something 2. Okay. Now, what is this? This, I think, is just a fancy way to have X of object. I think, right? Everyone agree on that one? I don't know.
You're creating a copy but not naming it?
It's gonna. Okay.
Yeah. Yes, Brian. It's just I think you're making a copy of that. So it's gonna make a copy, which is gonna be 3, maybe. I think.
Yeah.
And then
it's gonna immediately get destroyed.
It's gonna immediately get destroyed, which is 2. And then we call F, which is 4. Does this look right? Someone is actually.
That's what I was kind of thinking. Yeah.
Okay, so let's give it a try. Then so incorrect. So we said 1, and then it's gonna be 2 at the end, and then we said there is gonna be a 3. The problem is what happened with copy elision on CPAPA 17. That's what I'm actually, and then it's gonna be 4. So 1 and. So the question is it gonna be 1, 2, 4, and 2 because of copy elision? Is this gonna happen? No?
One, and then
1, 1, and then it's going to be distracted, which is 2. And then we call F, which is 4, and then 2. It's funny, it's still incorrect. So
should we take into account static order initialization?
So that's what I'm trying to use. Like this object would be first. So this is what we want. I just remember that this one is just a simple way to kind of create this object. If I'm not mistaken, some people actually have some.
Yeah, I think it's gonna be 1, 3, 4, 2, 2. Cause
1, 3, 1, 3,
3, 4, 2, 2,
4,
2, 2,
2, 2. So
yeah.
We did something similar, right? No. Yeah, we did, and it's
Okay. Okay.
Well, we had the destruction of the temporary before the 4.
So we
I
had.
think we had 1, 3, 2, 4, 2. Was our first attempt.
Oh, okay. So it's, but we tried also 1. So we had 1, 3, and we had 1, 1, and then so definitely we have 2 at the end because of the object, and we have 4. We have 2, 4. Question is it going to be 1 and 1? So this is what we had also. We already tried that, right? 1, 1, 4, 2, 2.
Oh.
No, we didn't. We didn't because we didn't. We said that there's gonna be a destruction of the object. So
I think you're on the right track, Kobe. I think it's 1, 1, 4, 2, 2. The copulation happens.
So 1, 1,
3, 2, 4, 2.
1, 1, and then
it doesn't destroy that object.
So it should be destroyed. But it's gonna be 2 objects total. So is it 1, 1, 2, 4, 2? We tried
1, 1,
that,
4, 2, 2. I think it's destroying that extra object
1,
at
1.
the end of main, actually. 1, 1, 4, 2, 2.
Yes. 1, 1, 4, 2, 2. Yes. So it's basically the destruction is not immediately happen. This is basically this X object. Let's see what happens when you put it in CPP Insight. This is what happens. So the confusing part, initially we thought it's going to be distracted immediately, but no, it's actually create this. It's basically X object.
Yeah, wow.
Yeah, it's actually not even. It's actually shadowing the outer one, if you think about it.
Yeah.
I wonder if is it W shadow? Yeah, there's a lot of. I thought W shadow would be. Yeah.
There you go. Yeah.
Here. Okay. Okay. So a couple things before. So we had 8 and 2, 5, 5. Okay. So let me just write it. We get 8. So couple book recommendation before we start with PMR. One is WebAssembly. So I have 3 books that I would like to point out that I used for my introduction to WebAssembly. One is by Manning, and I actually contacted Manning and Packet Publication to get permissions to use their images and all of that. So I actually started getting permissions from publications in order to use their content, and they are supporting us. So this is good, and thank you, Manning, and thank you, PacketPub, for supporting the meetup. And 2 of this WebAssembly from gaming and WebAssembly in general. And so two books that I looked online. I actually have subscription in PacketPub, so I have a way to kind of browse the books. The one from Manning is really, really good. It was MIP, Manning Early Access Program for quite some time, and just recently got published. And the reason I wanted to introduce WebAssembly, and I'll talk about it more, is because the technology is 5 years old. A few weeks ago, I think 3 weeks ago, it kind of celebrated 5 years ago, and I'll talk more about it in the overview. Two things that I wanna present is, one, there is a very good, fun to read that I ordered online, very well made by a person that he's actually the person behind Wallet Fox. I don't know who's the person. I have no idea, and in Twitter no one knows, but he has a lot of things that he publish online, and now there is a book. It's this thing. I actually have it. I can show it later, and it's really fun to kind of read. If you give me a second, I'm going to bring it. 1 second. Okay, so this is the book. Hopefully you can see it. And I'm just going to open something randomly. So this is how the graphics looks like. Let me see that I actually showing stuff that you can see. Let me see. There is. We need to remove this the blaring. 1 second. Okay. So you see. Okay. So you can see that it's really nicely made. I would definitely recommend purchasing that and learning about ranges P3. Lots of fun way to learn algorithms and ranges. It's a library that was the base library for ranges in C++20. The last thing I want before PMR is the Human Readable magazine. There are 3 issues that were published. A lot of good writers. Take a look at that. You can have it either as a soft copy or they can ship you a hard copy. They're trying to kind of bring more good content as a magazine. It's kind of initiative. I think it started like a Kickstarter kind of a initiative, and now they are doing well with the number of subscription, and also so that's what I had. I'm gonna stop sharing, and Arvind, you can take over.
Thank you, Kobe. Can you hear me?
Yeah, I can hear you.
So let me share my.
Arvind, maybe before you share, before you start, maybe just introduce yourself.
Sure. So hello, everyone. My name is Arvind Natarajan. I'm a staff engineer at Qualcomm. This is my second meetup, actually. So I joined the last ones, and we got an email, with the list with this meetup information. So it was really cool. I had no idea we had this, online meetup that was going on. So thank you, Kobe, for this opportunity again, to give a presentation on this topic. So today I want to give you all an introduction to Strict Pmr. I want to motivate the need for something like Strict Pmr, talk about some of its core elements, talk about some of the performance benefits you can obtain, and also end with an example of customization. So before I go any further, can you see my slides?
Yes, you can see the slide. I can hear you well.
Thank you. So why do we need something like Strict Pmr? So allocation is typically a slow process, or a slow, it's generally very slow. And typically, if you were to run your program through a performance analyzer, you'd find that majority of the runtime or the main hotspots of your program is where it does some kind of allocation. This could be a new or a malloc, and typically any kind of performance benefits that even a small improvement in allocation performance can result in a significant boost for your program. Also, repeated allocation and deallocation leads to fragmentation of memory. And what this results in is that you're going to have more cache misses, increasing the runtime of your program. And finally, prior to C++ 17, allocators were overly complicated. These are the standard allocators that were part of the C++ library. They were really complicated. So people tended to stay away from them or not use them at all, or develop their own custom memory allocators. So with Strict Pmr, the goal is to tackle all of the above problems. So the polymorphic allocator, which is a part of Strict Pmr, is an enhancement to the standard allocator. And it's polymorphic in the sense that the allocation behavior depends on the type of memory resource it is constructed with. So you can think of the memory resource as the owner and manager of the actual bytes, while the polymorphic allocator is more of a handle to the memory resource. And this memory resource object is used to perform the memory management. So there are template specializations of all the standard containers with the polymorphic allocator. Just as you would have Strict string, Strict vector, you have the equivalent Strict Pmr string, Strict Pmr vector, list, map, and others. And the cool thing here is you don't need to include any different header file. They're all defined in the same header file as the container itself. So here's an example, and this is a snapshot of the CPP reference page for Strict vector. You can see that the template specialization with the polymorphic allocator is just vector with polymorphic allocator as opposed to the standard allocator. And and these are again just contained in the header vector. So far I've told you, I've used the term PMR several times, but I haven't really told you what it stands for. Well, it stands for polymorphic memory resource. And all of the functionality of Strict Pmr is contained in the memory_resource header. So in your program, all you need to do is just include this header and you have access to all of the functionality. So the polymorphic allocator essentially contains a pointer to the type of to the underlying memory resource. And so you can use virtual method dispatch. So you can also change the memory resource at runtime while keeping the type of allocator. And this is a really cool feature, which I'll show you in an example in a few minutes. So the memory resource, as I mentioned earlier, is the one that manages the bytes and it operates at the level of raw bytes. There are several predefined types of memory resources. So the one that typically we would be familiar with is now called the new delete resource, which does allocations via new and deallocations via the delete operator. And this is the global default memory resource if it is not changed. There's also a null memory resource, which on every allocation just throws a strict bad alloc. Now, on the face of it, it may seem like, okay, what could one really do with this? But it's actually surprisingly useful, as I'll talk about in the next slide. There are also several pool resources, or actually two different types of pool resources. So there's the synchronized pool resource, which is thread safe and manages pools of different sizes. And there's an equivalent unsynchronized pool resource, which is not thread safe. And one other very important type of resource, and it's generally grouped with the pool resources, is the monotonic buffer resource. And I want to draw special attention to it, and I'll show you an example of this, is that so it's because this is a non-thread safe resource, but it is super fast. You can give it, so it gets memory from a pre-allocated buffer, and this buffer can be allocated on the stack. And the reason why it's, one of the reasons why actually it's so fast is that we don't release any memory with a deallocation. So instead, we just increment a pointer. And it produces excellent cache locality because the memory is generally contiguous, and so you get better performance in your programs by using the monotonic buffer resource. So the pool resources are typically used by creating objects of their type, and by pool resources here I'm referring to the synchronized, unsynchronized, and the monotonic buffer resources, whereas the null memory resource and the new delete resources are singletons. And finally, one very interesting feature is that the pool resources can be chained. That is, so for example, if you have a monotonic buffer resource created with, some memory allocated on a stack, once you exhaust that memory, and recall that with the monotonic buffer resource, we don't really deallocate memory, so you're quite likely going to run out of it, once you've performed enough allocations. You can rely on an upstream resource to get more memory. So if your upstream resource was the new delete resource, you could get more memory from the heap once you've exhausted that initial buffer. And so here's where the null memory resource plays a real important role. So in case an application programmer didn't want, so I wanted this behavior in the program that once they reach the end of their pre-allocated buffer, rather than going to an upstream buffer and silently getting more memory, they could instead catch an exception or detect that we have exhausted our buffer, and then handle that exception in some way so that depending on the behavior of the program, they could chain their monotonic buffer resource with the null memory resource. So clearly, the null memory resource has a lot of use in these kinds of use cases where you don't want to silently just get more memory and exhaust or exceed your pre-allocated pool. So with that, I'd like to show you all a bit of Strict Pmr in action, and I'm going to share my compiler explorer window. Sorry, it's just taking a bit of time. Oh. Sorry. Sorry, folks. Yeah, decides to go slowly today. So you see my Godbolt window right now?
Yes.
Okay, thank you. So in order to go through some examples, I'm going to first include IO stream. That's because I want to do some. Oh, sorry, already have a typo there. I want to do some std outs. Then I'm going to include memory resource again. Resource, which is the main header for Strict Pmr. Then I'm going to include vector because I'm going to do most of my examples using Strict vector or Strict Pmr vector. So and essentially these are the only header files that I need to use here. And I also want to point out that I'm not using any special flags in order to get PMR capabilities. I just have the std C++17 and the O3 and verbose ASM just for more clarity reasons. So the first thing I want to show you all is that the new delete resource is actually the global default resource. So I'm going to do std cout. I'm going to say std PMR new delete resource equal to std PMR get default source. And recall that I mentioned the new delete resource and the null memory resources are both singletons. So did I miss something? Oh, it's still compiling. So yeah, so sorry. So here, if you see the value is 1, so the new delete resource is in fact the global default resource. So now if I were to create a std PMR vector, and that's just created like this, and let me create a declare type int, and let me call it v1. Okay, and so this is internally going to use the polymorphic allocator. But then that is going to use the default memory resource underneath, which is the new delete resource. So when I do a v1.pushback of 1, it's using the new delete resource, so we don't really see anything, or it should just allocate 4 bytes and push 1 into the vector. So I'm just waiting for it to finish compiling. So yeah, so it finished compiling. So now what I'm going to do is I'm going to change the default memory resource to the null memory resource. Okay, and so the way you do that is just set default resource. Set std PMR set default source and to std PMR new delete. Oh, sorry, not new delete. I want it to be the null memory resource. So this has set the global default memory resource to the null memory resource. So now if I were to create a PMR vector of type int, let me call it v2, this is now created with a polymorphic allocator again, but that polymorphic allocator instance points to the null memory resource. So now I'm going to do this within a try-catch block just to show you all that we get a bad alloc exception. So if I do v2 dot push back of let me say let's call it 1 again. So then I'm going to catch by const ref const std bad alloc ampersand, and I'm just going to print std c out. It's got a bad alloc. Let's say bad alloc /n. Okay, and so since v2 again is created with the null memory resource essentially underneath, it should throw a bad alloc once the compilation completes and the program is run. So yeah, so here you can see that because we're using the null memory resource, it threw a bad alloc. But note that underlying memory resource for the allocator instance used for v1 is not changed. So I can still do a v1.push back of 2, and this should succeed without any problems. Okay, so let me just wait for that to finish. And I apologize for the bit of a delay. My system's running a bit slow, I think, with Teams and screen sharing going on simultaneously. So okay, so we have that. So now I want to show you all how to use the monotonic buffer resource. And so recall that I mentioned that in order to use a monotonic buffer resource, we pass in a pre-allocated buffer. And for this example, I'm going to allocate a buffer on the stack, and I'm going to use an array of std bytes. Okay, so the way I would do that is a std byte, and I'm going to say it's 64 bytes, and I'm going to call it buffer. Okay, so I've created this array on the stack. So now I'm just to make it easier to see what's going on, I'm going to treat this as a character buffer. So I'm going to first fill it up with the underscore characters, and that's because I want to illustrate how the allocations happen. Oh, sorry. And I'm going to say std byte of underscore characters. Okay, so I'm going to fill it, and then since I want to treat it as a string or a C string, I'm going to push a null terminator at the end. So I'm going to just do buffer.back. And I'm going to do std byte again of the /0 character. Okay, so this is my buffer, and let's just print it out to see what's going on. Sorry about that. So std out.
I think you need to have buffer.back and then equal std byte, because the buffer.back gives you a reference to the back.
Thank you, Kobe. Yes, thank you. Sorry. Yeah. So reinterpret cast. Cast, and I'm going to cast it as char star. Okay. And then this is going to be buffer.data. And then I'm just going to do a /n. So we should see a once the compilation finishes, we should see just a long string of underscores. So yeah, this is the string of underscores. So now that we have this, I'm going to pass this to my monotonic buffer resource. So I'm going to say, so the way I would do that is I would create a monotonic buffer resource, Strict Pmr monotonic buffer resource. And then, so then let me call it rsrc, and then I'm going to pass it a pointer to the buffer, which would be buffer.data. And the size of the buffer. Okay, and so now I create a Strict Pmr vector. And then, I'm just going to use char again just to make it easier to see what's going on in the code. Sorry, with the printfs. So I'm going to just so Strict Pmr vector. Let me call it char vec. Okay, and that I'm going to create using the buffer resource that I created. So it's going to be a pointer to the monotonic buffer resource. So rsrc. Oh, the semicolon at the end. Okay, so now I've created my buffer using this, underlying monotonic buffer resource. So now let me just push, some characters onto the into the vector. Okay, so I'm going to say for char ch equal to a, ch less than equal to z. Oh. ch plus plus. Okay, and then I'm going to char vec dot push back ch, and then let's print out the contents of the buffer resource. Sorry, the contents of buffer just to see what's going on there. So yeah, so we should see the buffer start to get filled up. And let me just wait till it finishes. So yeah, so here we see the output. So if you see why we have this kind of weird string here, it's because when initially the buffer is created with just one element. So and you push A in. So when you try to push B, the buffer is full. So you allocate a vector of twice the size. So you then push A and B. And now when you try to push C in again, your buffer is full. Allocate twice the size, so size 4. So you push A, B, C, D. And then when you try to push E again, it's again full. So that's why you have this, weird string, and then essentially, once you get to that point, you've finally allocated a buffer of enough size to push A through Z. And the other thing I want to also stress here is that none of the memory is deallocated. So you can see that, you have all these allocations here and, the subsequent allocations are happening after the preceding ones. So now, we have this buffer allocated and, we've seen this kind of pushing. So from previous testing, I know that there's about 6 entries left. So I'm going to push another, A through F into it. And, this should technically fill up the entire buffer. I'll just wait for that to finish. So yeah, so you can see here that, it's filled up the last 6 elements that were previously not filled up. Now, now if I try to push, a G into the char vec, okay? So char vec dot push back. Push back G. I'm actually going to end up with a bad alloc because if you recall, I had set the global default resource to the null memory resource. And so when I created this monotonic buffer resource, its upstream resource became the null memory resource. So, sorry, so let me just, started talking. So let me just catch this constant bad. And then may say std C out again. Add alloc 2 because yeah, this is just for the sake of this example that I'm adding these kinds of C outs here. Oh, sorry, I forgot the semicolon after pushback, and I forgot a second colon here. So hopefully this should compile. And once it does, yes. So you can see that, once I try to push G into the character vector, I end up with a bad allocation. So yeah, so and then just to show you all that that this is why this happened. If I were to let me reset the default resource back to the new delete resource, so that we don't see this error anymore. Pmr new delete. Yeah, so this should fix that issue, and we should not see it anymore. So
does it then increase the stack allocation?
I'm sorry, I didn't.
If you change to using a new delete resource,
Yes.
does it increase the stack allocation?
No, it does not. So it basically fetches a, it allocates it on the heap. So it's not changing the buffer itself.
Okay, cool.
Okay. So yeah, so this is essentially what happened. So you can see that I'm no longer getting my bad allocator again. So now I'd like to come back to my slides, and unfortunately it's going to be very slow. Sorry, it's a bit loud. Could people mute if they're not speaking? Thank you. Thank you. Sure. Sorry. Teams running slowly again. Maybe I should just share my desktop rather than doing this. Yeah. Sorry, guys. Sorry. Oh, crap. I shared the wrong video. Oh, I think I probably reshared. So, yeah.
Hey, Arvind, I have one question. I'm trying to process this with the monotonic buffer.
Right.
Why it was trying to reallocate the buffer so when I see that it allocates A and
right.
and it uses that, but the second time it did not find the space, so it is reallocating and then it is pushing back all of the buffers, is what you said?
Yes, so that's how std vector works. So std vector essentially, when it gets full, so sometimes I think there are different implementations where it gets more than half full, it allocates a buffer of double the size and then copies the contents and pushes the new element in. Or it could be like in this example where if it's allocated, so if it is full and then you try to push something into the buffer, then it allocates a buffer of, it allocates a vector of 2x the size and then pushes all the elements of the existing vector into it and then adds the new element. So std vector actually is not very efficient because of this. So, they in fact suggest using something like std dec, DEQUE, in order to, have that kind of chaining behavior where you don't need to allocate, a chunk of twice the size and then copy over all the elements from the previous chunk. Does that make sense?
Yes, absolutely. Thank you very much. And the other question is like finally, when you use it, the new delete resource, it should have printed the G at the end, right? It should have.
Oh, no. So this is the, so we exhausted our buffer. So that was created. So it actually ended up allocating on the stack, on the heap. So since we've exhausted the, and I was only printing the stack allocation.
Got it. Okay.
So you need to go start printing out from the heap address to finally be able to see the G. Yeah.
Yeah. Thank you.
Another question. If we know the amount of elements, I guess, that we want to add to the vector, why can't we just use vector reserve?
You could, yeah, you could. You could potentially, yeah, you can use it, in fact, even with monotonic buffer resource. You could do a vector reserve. But vector reserve, if I remember correctly, does not actually do the allocation. I may be mistaken on that, but while it doesn't, create that buffer of that size.
It would. Reserved is actually dealing with the capacity.
Okay.
So,
yeah.
So it's actually going to allocate upfront the capacity that is needed. So the standard, if I'm not mistaken, guaranteed to have at least what you want. It might be more.
Right. Okay. Yeah. Sorry. I think I was trying some example with vector reserve and it didn't do what I was expecting. So I thought I came to an incorrect conclusion. But yeah, you could do it, but it would end up using the monotonic buffer resource. And if you do exceed the bounds, then yeah, you go to the heap if the underlying resource was the new delete resource.
Okay.
All right. Any other questions? I think my slides are back.
Yes, we can see the slide. Yeah.
Yeah. So so far I've shown you how to use the monotonic buffer resource. So I thought it would be nice to see what kind of performance benefits that results in, right? So I wrote a simple benchmark, and I ran this benchmark on quick-bench.com. This is actually a pretty cool website I came to know about very recently, where you can run these kinds of micro benchmarks and see. Of course, it runs on a different server, but and the reason why I didn't actually run it in the middle of this exercise is because it takes about a few minutes, and I didn't want to have that dead time there. So I ran this before the before this talk, and all I'm doing here is just creating two vectors. One I'm using actually let me show. Let me have the laser pointer. So yeah, for one, I'm using the general for the regular vector benchmark. It's just just creating two std vectors of ints, and these contain 20 elements. And the reason I'm creating two vectors is because typically in most programs you have multiple container allocations. And similarly for the PMR vector, I'm creating a monotonic buffer of 2048 bytes, and then I'm using that creating a buffer of 2048 bytes, and then using the monotonic buffer resource created from that buffer. And surprisingly, this simple benchmark, with the PMR vector, we can see that we get a 2.3 times faster performance than compared to the regular vector. So this is really really quite impressive to see that even with such a toy benchmark, you can get this kind of a performance improvement. And similarly, I created a list, a std list and a std PMR list. And here again, we can see that we're getting 2.5 times the performance of the regular list. So clearly, monotonic buffer resource, using it in your program could get you significant improvements in performance. So I encourage you all to try it out and try to make use of it if you can in your code. So finally, one thing I thought would be interesting for people to learn or see is how would you create a custom memory resource? So far we've talked about all these different resources, right? So let's create a custom memory resource, and that's actually very simple. So all you need to do is inherit from the abstract base class memory resource, and then override three pure virtual methods in that base class. So there's the do allocate, do deallocate, and do is equal methods. And I'd like to walk you guys through an example of how to do that. So let me go back and reshare my Godbolt screen. Sorry, I didn't foresee this slowdown in my system. Okay, so let me know when the screen is visible. I hope it should be. Yeah, I think it should be now. Sorry, is my screen visible?
Yes.
Okay, thank you. So I'm going to create a class test resource. And I'm going to mark it as final because I don't want anything to inherit from this, but I'm going to publicly inherit from std PMR memory resource. Okay. My class. So I'm going to cheat a little bit in this example, and just because we're pressed for time, I'm going to use an underlying existing memory resource, essentially the new delete resource, to perform the memory allocation and deallocation itself, because I don't want to have my own pools here, just to make this a simple example. So I'm going to create a I'm going to have a data member, which is a pointer to the memory resource. Underlying memory resource, underscore star, and I'm going to call it underlying resource. Okay, this is my only data member. So now I have three public functions. Three public member functions. So including the constructor first. So my constructor is just going to take a pointer to a memory resource and assign it to the underlying resource. So since it has only a single argument, I'm going to mark it as explicit. So I'm going to say test source and cons. Oh no, so it's not cons. Sorry. Good. Memory resource star. I'm just going to call it m_r. I'm going to mark this as no except. So, and all this does is essentially assign underlying resource to m_r source. Mistaken spelling. Hopefully not. Okay. So now recall that there were three virtual functions that needed to be overridden. So the first one was Deallocate, and so since we are going to return a void star here, I'm going to mark this as no discard. Void star Deallocate. And so this takes in a size t bytes and a size t alignment. And this is going to be marked as override. And so I'm just to convince you all that we are actually using this allocate method. I'm going to do a cout here, and I'm going to just say allocating bytes. And then we're going to just call the underlying resource slash arrow allocate. This is going to be bytes. Okay, so this is the Deallocate method. So the next is the Deallocate method, which returns which is a void method. So I'm just going to say do_deallocate. And so this takes in a void star pointer. Then it takes in the size t of bytes and size t align. This again is override. And so this is again just going to call the underlying resource. Deallocate enter bytes and align. Okay, and the final method is the do's equal method. And since it returns a bool, I'm going to again mark this as no discard. Bool do is equal. And then this takes a const ref to another memory resource. So const Pmr memory resource and other. And this is a const method because it's just returning and is equal. So I can. It's also a no except because it does not throw anything. And override. And then I'm just going to say return underlying resource is equal other. So and that's all that's essentially all you need to create your memory resource class. So now if I were to use this memory resource that I just created, so I'm going to create a static memory resource of type test resource. And the reason why I'm creating a static, I'll just get back in a little bit. So static test resource, I'm going to call it tr. And I'm going to create it with the new delete resource. So Strict Pmr new delete resource. Okay, so I've created that. So now I'm going to create a Strict Pmr vector out of that test resource. So Strict Pmr vector. Let's create it of type int. Why not? So I'm going to say v3, and I'm going to pass in the address to my test resource. So t_r, and I'm just going to do a simple v3.pushback back of let's say number 3. Okay, and hopefully this doesn't complain about anything. And so you can see that we've used our test resource, and then through our it invokes our Deallocate method, and we see this output of allocating 4 bytes. So if I were to just do another pushback of and this goes back to actually the question that had come up earlier. So now if I were to, if you do that pushback of 4, you see that now we're allocating 8 bytes because we first we need to allocate a buffer of twice the size and then copy the first element in and then push the second one. So this is this is essentially how you would use your memory resource that you would create. And sorry, coming back. So the reason why I created this as static is because you want this this resource, this memory resource object, to outlive any other containers that are created from it. For example, if you had a program where you created a test resource and passed the pointer to that resource to another function, where let's say you created a std vector, static std vector. If that vector's lifetime was greater than the memory resource, you end up with either memory leaks, or you go into undefined behavior at that point. So you definitely want to ensure that any objects or containers that are created out of your memory resources have a longer lifetime. Have a lesser lifetime than the memory resource object itself. So that's pretty much what I have for this. I have some resources that I used in order to prepare. I can share that. Let me go back and let me reshare my slides window.
So does the memory resource, is that tied to the underlying buffer? So like, let's say I do like a move or something of a vector. Does the place that I'm moving the vector to now get that memory resource?
That's a good question.
It's a very good question, Michael. And Arthur Dwary book has a chapter just on this, and I read it maybe a couple of years ago, and I can't really remember the answer. It's not it's kind of a simple answer to this. There's all kinds of corner cases. So I need to go back and read this chapter again. So Arthur Dwary, he's someone in the committee, and he has a lot of talks, and he co-hosting the C++ meetup in the Bay Area, and he has a book, a very good one, about STL with C++17, and I read it just like when the book was out, and there is a chapter on that. I need to read it. I don't remember, but it's a good question.
Yeah,
and
thank you.
I remember he was like bitching about it a lot, that it's not working so well if you try to move it and all that stuff.
Yeah. Thanks, Kobe. Yeah, sorry, Michael, I don't know the answer to that. I'll defer to Kobe on this one.
I don't remember. I used to remember it, and I don't remember it. The nice thing about, thank you, Arvind, very good. I really enjoyed it. And the nice thing about it is that we can actually use this this mechanism with all kinds of sophisticated containers like studmap, and that you definitely don't want to use them in a critical path. Need low latency, low jitter, all of that. but now you can actually achieve locality and contiguity and all of that with PMR, either monotonic or anything else that either you cook yourself or someone else is having. And I think it's much better in terms of usability compared to the previous allocators that we had.
Right.
Hey, Arvind, I have one question. Just
Sure.
curious. You had this benchmarking results, right? Now,
right.
Compared to the other allocators, do you see any storage related overheads, in your benchmarks with this polymorphic allocator?
So, so the monotonic buffer resource uses the memory allocated on the stack. So clearly, that's much more efficient than going to the heap and getting more memory from there. So definitely, the monotonic buffer resource would be much more performance efficient compared to the regular standard allocator, which would potentially allocate from the heap.
Okay, thank you.
Mm-hmm. Any other questions? All right, thank you for listening. So Kobe, I'll hand it back to you.
Oh, thank you. So let me share my desktop. So I'm going to talk about WebAssembly. I have about 40 minutes to go over that. And the way I structure that, it's like the first half is mostly kind of general explanation about WebAssembly. You can see my slides and you can hear me, right?
Yes.
Yes, cool.
Okay, thank you. So the way I structured it is the first half would be kind of why WebAssembly, why not JavaScript, what is the shortcoming of JavaScript, and so on and so forth. And then we'll go into how, like, introduction of how the blocks of the process of creating the binary. And at the end, I'm having a one second, please 1 second. Sorry, and I'm going to show you a very quick demo on how to use WebAssembly in the browser in Chrome. And so here's basically what we're going to cover, like what the motivation and what JavaScript lacking and so on and so forth. The thing actually that triggered me having WebAssembly is multifold. So first of all, I heard about WebAssembly, I think around 2008. So WebAssembly was officially kind of being created as a technology, and Google was pushing it very, very hard around 2015. So 5 years, and a few weeks ago it had like a birthday of 5 years. And I remember first seeing the Manning book that I mentioned before, where it was just a MIP, and I started reading about it, and I said, wow, this is actually a cool idea, because I remember that Google tried very hard to have this native client, and all this sandboxing in browser was something that people tried a lot in all kinds of, and I'll go over a couple methods, and I think it's a very cool technology, and it has a lot of opportunities, especially when the world is slowly moving into the web. So you want to have it, you want things load faster, and you want it to be running faster, and all of that advantages of binaries versus JavaScript, which is it's not a compiled language, but it's interpreted language. And in addition, there was a podcast that I listened from CPP Cast. It's a weekly podcast on C++ by two people. One of them is Turner, Jason Turner, and the second one is Rob. I forgot his last name. And they interviewed someone named Ben, and hopefully you can see my screen. So Ben Smith gave a keynote talk on WebAssembly in 2019, and I attended this in person. It's a great talk. If you want to take a look at that, go ahead. It's an hour and a half, because it's not a regular 1 hour talk. It's more than that, and actually it kind of ignite my interest in WebAssembly, because I see that it's getting more and more mature, and more people are actually using it. And it's not only C++, it's spanning different languages like Rust and other, like C, C++, Rust, other languages that I definitely know that people working on. So why WebAssembly? So first of all, we know that speed is the most important thing in the web. It reminds me, I used to work in a startup at the end of the 90s. And what we did back then was, so there was no broadband internet. It was all dial-up and very low speeds. But we had this technology that someone had as a kind of it came from a PhD work, that someone had an idea to compress vector images and be able to transmit that. And then there was a player that that actually played this this content, and we actually went to Newman Marcus. It was it was back in Israel. We went to Newman Marcus and other retailers to kind of show them that we can give this nice experience of users in a 3D manner, and it was very interactive. And the reason for that is that even back then, I remember we were looking at statistics that people, I'm talking 20 years ago, even 20 years ago, people were very fast, in the sense that if the page is not loading fast enough, they'll move to a different page. So there was a statistics that I can't remember 20 years ago, but what I found was that within 3 seconds, if it's not loading, 40% of your visitors will leave. And every second, this percentage would increase. And think about if you want to have a shopping website, or then you don't want people to leave. Otherwise, you lose money. And what about applications that are moving to the web? So think about Chromebook, and think about everything that we have today. We basically do a lot of things on the web. I don't know, like what is Microsoft online Office? I don't know. I don't remember what's the name for that. But there's like Office Online and Google Docs and all that. What they use underneath, I don't know if it's WebAssembly or different mechanism. But there is a lot of potential to something like WebAssembly. So this is really, I think it's a very exciting technology. And I remember talking back in 2018 when I discovered that. I was talking with someone that I used to work with, and in Qualcomm, we're still working together, just different department. And we used to do a lot of statistics on the web with JavaScript, and we were hitting all kinds of limits when we tried to do a lot of cool stuff and computation and all that. We would hit the limit of JavaScript, and I used to back in 2018 I sent him an email and said, look, this new technology. And a few weeks ago, when I started thinking about having this WebAssembly, I also emailed him and said, look, this is actually getting more and more popular, and he actually liked it, because it's a really good opportunity for us to to improve visibility of the web. So currently, the dominated language is definitely JavaScript. JavaScript actually it wasn't in, like what we have today, it's pretty crazy. It wasn't intended to be, this amount of code. It's huge. Today, JavaScript is like, it's dominating the web. It's huge. From what I was reading, it was mainly intended to be a glue between different architectures and technologies, but not the main thing. It was just not designed to do all this heavy lifting that we do today. And there is this JavaScript, the good parts. I don't know if anyone had the chance to look at this book, but it's very thin. I don't know how many pages we have here. 176. Believe me, it's a very thin page. This is the good parts. Not a lot of good parts. So this is pretty funny. The JavaScript is not. It's lots of surprises when you deal with JavaScript. So this actually led browser makers like Mozilla and others to define kind of something else, which is, so the first thing that I found was ASM.js, and it's predated WebAssembly, and I'm going to use WASM as a nickname for WebAssembly. And the idea was that you write something like C and C++, and it's being converted to JavaScript. Like you translate plus compile it to JavaScript. And it did bring better code execution to the browser. You would have this use ASM keyword, and there would be a type hints. So JavaScript engine doesn't need to always monitor the type. So this is something that I'll keep saying, that one of the issues of JavaScript, because it's dynamic language, it always needs to kind of monitor the types, and because they might change. And with ASM.js, the code is compiled once. It's kind of like a JIT, just in time kind of compiling. And it's not need to be monitored anymore. So, which is not the case as regular JS. Regular JS needs to be monitored. So here's an example that I found in Manning book, WebAssembly in Action. By the way, it's a great book, very readable, very fun to read. If you have a book club in your company, it might be worth adding it sometime in the future to the list. And so here's an example of a function, but there was some shortcoming. Although it doesn't shown here in the file like the type-ins, but what I understood is it's actually the type-in actually bloating the file. There's more verbosity, and at the end of time, ASM.js is a JS file. It has this use ASM, but it still needs to be read by the JavaScript engine, and it's expensive. Everything that you start adding to JavaScript and you think about embedded like phones, it is expensive. Expensive means more battery, more power, all of this like CPU. JavaScript is expensive in general, so we want to reduce this expensive operations. Mozilla and others, they realized that in order to add stuff to ASM.js, they actually need to modify JS language itself, which is not super ideal. Look, JS basically went through different revisions and was hardened, and the idea was that it's safe enough, and adding things to JavaScript is a risk, and since it's already hardened, you don't want to add anything, or maybe reduce the amount of changes to the language. It's stable, you don't want to destabilize it. The last thing here is that it was really hard to continue shoehorn WASM in, not WASM, but this is not WASM, but ASM.js. No, this is actually, it's a typo, not WASM, but ASM.js into JavaScript. because it's not designed to be kind of a compiler that takes a piece of code, compile it, and then use the binary. It was just by design, it wasn't there. So this actually led browser makers to think about different approach, which is basically thinking about, okay, what was good in ASM.js, what can we take, what was not good, and let's rethink about the solution. And they came up with WASM MVP. So basically that's the name. It's WebAssembly Minimum Viable Product. So, but I'm not going to use MVP from now on. It's going to be WASM only. And 2015 is where the whole thing was kind of in the inception of the whole thing. And in June, we celebrated 5 years. WASM is a low-level language. So we'll see the different phases from C, C++, Rust code, all the way to binary. But it's a low level. It's basically eventually compiled to machine language. This is the host machine language, and that's it. We run it, and it's much more efficient, and it's designed to be compact. The layout of the binary is designed to be compact. It can be transmitted faster over wireless mediums and wireless constrained bandwidth constrained mediums. The way it was designed, it's more kind of in depth. We're not going to go through it. I'm just going to show a quick layout of the file. It was designed to be parsed in one shot, just one pass, and so no jumping between different sections, just one pass. Again, it's a new format, so they had enough experience to design something really well. So just one pass, and you quickly initialize it. And as I mentioned, it's C, C++, Rust, other languages that I'm. And there are books for Rust, for example. You can go, and there are websites that can show you how to work with Rust on the web. I'm going to stop right now just to make sure that no one actually asking anything. Okay, fine. So I'll continue. So the idea with WASM is let's make it as close as what you know from your own compiled language, like C or C++ or Rust. So you can have libraries, you can use it for heavy computational code. And the fun part, which I actually didn't try it, it's like once you run it, it's like a VM. I didn't try it outside of the browser, so I don't know which tool need to run it as to host it as a VM outside of the browser. But it is designed to be run both in the browser or outside of the browser. Think about it like a VM, which I think it's very excited, because it's kind of, they can take it and once you have this something that hosts it, you can run it everywhere. So just to recap, it solves the performance. This is the main goal of WASM. Faster download, faster execution. You don't need to write machine code in order to achieve fast code. You can write higher language code and be done with it. And just like I mentioned, JavaScript is interpreted language. I know JavaScript here and there. I'm not an expert. The engine, the JavaScript engine, is reading the code on the fly. It doesn't really compile it. With a small kind of disclaimer, there is, from what I understood, the engine can detect parts of the code that actually repeated and optimize it. So it can stop, optimize it, and it still monitor the code, because it can still, but it's another level where it doesn't need to be going through a plain interpretation, but there's some compilation of the code can be done. But it's still expensive. This whole thing is still expensive. And this last bullet says that we can actually optimize, for example, a loop. But the optimization takes time. There's going to be some hiccup. I don't know if it's milliseconds or more. I don't know if tens of milliseconds or 100 milliseconds, but there's going to be a hiccup to do that. C++ is not interpreted C++ just like every other compiled. You invest time to upfront compile it ahead of time, and then and you have more time for optimization because everything is done offline. And the second bullet is what I mentioned. JavaScript was not mentioned to do what it's doing today, but it's a huge code base. It was just designed to be a glue, but it's not a glue anymore. It's actually running the web. By the way, WebAssembly is not going to replace JavaScript. This is something that I remember from Ben's talk or other, or maybe from the podcast. It is designed to live side by side by JavaScript. I don't think we can replace JavaScript. There's too much code out there, but we can actually improve the web by start introducing WASM to the web. What else here that I didn't mention? Yeah, everything here I already mentioned in previous slides. WASM is going to give us a faster startup time because it's a binary. There is a small IR. IR is intermediate representation to the host machine code, and so we get a binary bytecode, and which represents a specific binary format. It's not a text format, but it is smaller in size compared to text format, and this could be compiled to the host architecture. It's statically typed, so everything known ahead of time, no need to monitor that. And there is this fourth or fifth, it's actually fifth bullet. There is a mechanism that you can actually start if it's a relatively big WASM bytecode IR. You can start streaming it. So this is cool. You can actually start compile portions of the IR and start executing it before you get the whole code, which is, I think, it's a cool idea. So WASM technology is opening the web to other languages, not only JavaScript. Before that, we had this ASM.js, and there was native client, and I'll talk about it in one slide soon. C and C++ were given priority, by the way. The focus was C++. I think just because maybe 2015 Rust was just in the beginning, and C++ were like, okay, let's start with that. There's some other experimental languages, but I definitely want to take a look at how Rust is being used as in WebAssembly. So this is also on my to-do list to look at that. Yeah, code reuse is a big advantage. Think about it, just a C and C++, and you can actually start building libraries, WASM libraries. So I'm going to show the diff between JavaScript and WASM and other things. So this is basically how JavaScript. This is for Manning. Again, thanks for Manning for supporting us. You have a text file, and it's being compiled to machine code, and it's being like interpreted and run by the browser. So this is basically how it's executed. WASM, on the other hand, is not interpreted at all. So first, C++ or C or Rust is compiled to WebAssembly. The book is focused on C++. This is why most of it will be C++. So first you have this IR representation, which is a kind of a bytecode. Then when the browser loaded, it would be compiled to the host machine code. So this is two stages. So you could argue that we could upfront have the backend compiled offline to all kinds of architecture like x86 and ARM, but this is actually not it's suboptimal. This is not gonna happen. In reality, what happened is that you have this from IR, you have this WebAssembly backend that is being shipped to the browser, and then the compiler, it's loaded into the browser, and then it compiled to machine code. So there's gonna be some small hiccup, but smooth sail from this point on. And it was designed to be compiled very fast and all. So so it should be very not noticeable. And I have a quick example. I don't know if we can actually derive the speed from that, but definitely there's a lot. I have in few tabs, I have all kinds of examples of games that people develop with WebAssembly, and it's a growing technology. By the way, the C++ committee is spending time on that, so it's pretty serious. I don't think that this technology is going away, and Google is behind it. Let me see if there's anything else that I missed here. Yeah, there's some things that are kind of nice to know, that the web workers would pick it up. Like there's a threading and all that happening with WASM, and this last bullet talks about what I mentioned. It's being designed to be easily validated with a single pass. One thing I wanted to mention is native client, just to give you another perspective of things that happened before WASM. And I actually had the chance to work on Chrome OS a long time ago, maybe about 10 years ago in Qualcomm, and this is where I actually got familiar with native client. This is one of the attempt of Google to have a safe excuse me, a safe sandboxing in Chrome and other browsers. So I think native client was mostly Chrome, if I'm not mistaken. So it was like it's basically sandboxing to run. So you know that there's this app store, the Chrome app store, and there's all kinds of plugins. So that was the idea, was to basically host these plugins, and basically they wanted to do the same as WASM, but it didn't fly. WASM today is capable of SIMD, and it has a better security than native client. And the idea of native client was very similar. So you can probably imagine that people take all kinds of ideas. So there was native client, NaCl, and Pepper. If you know chemistry, you understand why Google picked NaCl and Pepper. Anyone from chemistry or know chemistry about what is NaCl and why Pepper? Salt. It was funny when I discovered that when I worked with them. Yeah, why NaCl? But it's native. It's short of native client. So salt and pepper, and so Pepper was basically just a platform and an open source API to create native client and enable communication between the portable native client and the JavaScript, like a kind of a glue between these two. Then again, didn't fly. I don't even know if there is a stuff like that anymore, or people using it anymore. Maybe some leftovers, but so WebAssembly is communicating with Web API using JavaScript as proxy, and there is work in progress to make it communicating directly to the DOM and JavaScript and all of that. But this is still work in progress. There's a lot of it's basically moving target. So if you buy books like the Manning book that I showed, maybe in 2 years from now, it's not going to be up to date anymore. But that's fine. This is the nature of technology. It has 32 to 64-bit integers and same for floats. Booleans are expressed using integers. So this is the main types right now. It might change. there is a module that you not expect to create by hand. There are tools to create it, and the tool that I used was mscripten. I don't know if I pronounced it correctly. By the way, I kind of forgot to ask, and I'm kind of interesting. Anyone like heard about WebAssembly before that? Like, kind of raise your hand, just out of curiosity. Oh, that's nice. Anyone tried it, by the way? Like in either a toy project and playing it? It was on my to-do list for 2 years. I'm so happy that I made myself playing with it for the meetup, because that's the only way to kind of do that. So it was pretty fun. So okay, good to know that some people actually play with it. So this is how it looks like, the file structure. So there's a preamble and functions and all of that. And again, it was there is a chapter in Manning just explaining this whole thing. So we're not going to go into details. But it was designed to be very fast. The parsing was designed to be very, very fast. Quickly on security, it has, like, first thing is like security in mind. It's really sandbox, doesn't have access to device memory. If you listen to CPP cast podcast with Ben so he explained about memory. So you get a chunk, and this is the chunk that you can use, and that's it. So you don't really have access to the device memory. So there is a real sandboxing here, which is pretty safe. Yeah, I mentioned that there is no access to the DOM. This is work in progress. Okay, we have exactly a few minutes to look at the demo, and the Manning, basically the book for Manning today is really up to date, and I used Ubuntu 20.04 to try it out, and I was super surprised. Usually when I start playing with it, this kind of technologies, there's a lot of things you need to do. This was very smooth in terms of, like, I think it was like you clone, you run a command, and that's it. You have the environment primed to there is an EMCC. This is the compiler to take C++, run it through this EMCC mscripten compiler, and then it generates. The nice part is that it generates everything for you, all the HTML and there's a lot of boilerplate that you don't need to write, and I'm going to show, because it's pretty, if you want to look under the hood, it's pretty fun to see how things are actually being done in the web, how they're actually loading it and all. So this is where I actually went and downloaded the mscripten. Actually, it's basically Git clone. And Manning has a lot of code, a lot of example code. As you probably know, they are very good at providing code. You don't need to be to own the code. I don't think you need to own the book in order to download the code. I think just point your browser to the page, and there is a source code link. You download the zip, and it has everything. I'm going to show just one example of calculate primes.c. This is just a C file, but it's a C++ files would work as well. And so the source is basically the .c, and there is a one-line shell script and a one-line batch file for Windows. And it's just one line to help you run the compiler. It's just a compiler command, EMCC compiler command, and it generates all the files for you. So this is the command. So you can see here, EMCC calculate primes, and then output of the HTML, which will generate the JavaScript and then HTML for us. And if you run file, the file command on the WASM, it would say HTML template.wasm. It's a WebAssembly binary module version 01, MVP. So remember this MVP? Viable product, minimal viable product. That's the type. So the prime is pretty simple. This is from Manning code. Super simple, and this is the main. So this is the function is prime, and if it's prime, it's going to print it. So it's go between 3 to 100,000, and basically that's it. So once you have you run it through the script, and you get these 3 files, and you can run it. And what I'm going to do, I'm going to open the HTML file in the browser, and you're going to see that. So wait a second, let me see, where is it? Here. So this is the file that I run. So what I did here is I have a Python HTTP server that. So if you look, oh wait a sec. I need to share my entire screen. 1 second. Someone is asking something. So Merrick is asking if Wasm has potential to grow larger than JavaScript over years. I think my opinion, and just hearing experts, is yes. And again, Google is behind it, so I think it would be more and more common to see JavaScript on the web. I think there's a lot of potential. Like honestly, if the next thing that if I need to have something heavy as a let's say I want to show plots and statistics and I want to do computation, and I see that I'm hitting JavaScript limit, I'll definitely think about WebAssembly now that it's much more mature versus I know 10 years ago when I had these projects at my day job. So let me share the entire desktop. So you see this one. There is this is chapter 3, and I just created a virtual environment just to install a couple Python things, and I just wanted to have Python web server on 8,000. So this is what I have, and I just browsed to this chapter 3. So you see this is chapter 3. There's a lot of things here, so this is the Wasm file. So these are the sources that I mentioned, and this is the Wasm file. So when I run the HTML, you can see that from 3 all the way to 100,000 primes would be printed. And the nice thing would be view page source. So HTML template. So all of these boilerplate of HTML to just have this text box and whatnot. God knows, barely readable. And eventually there is a script. Everyone sees that, right? So eventually there is a script. So let's take a look at the script. And this is all, again, this is scripting. It's MIT license, and again, lots of boilerplate to get this environment in the web. We don't need to deal with it, but what I wanted to show you is the following. So first of all, so there is a variable that there wasn't binary, and there is the get binary. So again, all this, you don't need to write all these functions. Actually, nothing you need to write here, right? And the fun part is that there is an entry point named main. Yeah, call main here. So function call main. So you know that main gets argc and argv, right? So here it is. And in our example, it's pretty simple because main is actually invoking the whole thing, and that's it. But you can be more sophisticated as needed. Anything else I wanted to show here? I think not. I think everything here is pretty just boilerplate. But this module is what is it's the WebAssembly module that is being loaded somewhere up, and basically that's about it. What I wanted to show before we finish is that I have these 2 slides with resources, lots of resources. So I have this CPP cast about WebAssembly. That this is the guy, Ben Smith from Google. Rob and Jason interviewed him. This is his YouTube talk. Level Up with WebAssembly. This is actually a cool website. There's a book. It's pretty cool, and this is an example of what you're going to build from this book. So there's a lot of cool things that you can have actually, and there is a link to this medium.com article that I read, and was actually, it's the same thing that I showed you, but just explaining this whole thing. WebAssembly.org is everything you need to know about WebAssembly. This is Mscripten. It's very good API documentation, everything you can think about. And this is basically what so you do git clone, cd, pull if you want to get the latest. But basically, it's if you just install and activate and do source and you're done. Your EMCC would be available for you. It's very, very easy. There's a lot of WebAssembly games that you can take a look. And what else? I think that's about it. That's what I wanted to show you. Any questions regarding this? It's 8 o'clock sharp. 8 o'clock. It's actually 8:02. So so thank you everyone for attending that. Hopefully you learned 1 or 2 things from today's session. Thank you, Arvin. Great talk. Give me the slides. I'll upload them. And
Sure.
Thank you. And please volunteer for having something short, 15, 20 minutes or even more. It's really up to you. It's just fun and informal. We're just learning new things every day. Thank you, everyone. Bye-bye.
Bye-bye.